Pre-Calc, we're starting lesson 2.1 and we are talking about quadratic functions. So there's going to be a lot of Algebra 2 coming out of this. So hopefully you remember that Algebra 2. All of Algebra 2 is quadratics. Our essential question is, can you write the standard form of a quadratic equation? So let's start with the definition here. The definition of a quadratic function is let a, b, and c be real numbers where f of x is equal to ax squared plus bx plus c. You've seen this before, and there's so much you guys know about quadratics already. So let's talk about things that you do know. The first thing you know, it is a U-shaped curve graph called a parabola. And what you know is inside that parabola there is a pattern: over 1, up 1, over 1, up 3, over 1, up 5. And you guys have got this down. All parabolas are symmetric with respect to the line called an axis of symmetry. What you know about the axis of symmetry is that x is equal to the opposite of b over 2a. And then to find the y point, we just plug that in. So we'll get to that. Or, you know, on your calculator, you could hit second calc and find the minimum or the maximum, and that is the axis of symmetry. Great things, great tools to use. The vertex is at the minimum or maximum. So it's sounding like the axis of symmetry and the minimum and maximum might have something to do with each other. So let's go ahead and start by looking at example 1. It's telling us to sketch and compare the graphs. Because of the knowledge that I know, I'm going to start by graphing this right here. And yes, eventually we could use our TIs. 2, 3, 4, 5, 6, 7, 8. So I know that any parabola is going to have that pattern: over 1, up 1, over 1, up 3, over 1, up 5. So I'm going to graph the first one in orange. From this point at 0, 0, I'm going to go over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, 5. Woo! And this one is a parabola that has that perfect square pattern. Now, where do I get over 1, up 1, over 1, up 3? Remember, anything squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. These have a pattern of 3, 5, 7. So anytime you see odd numbers, you should think of, that's inside of the squares. All right, now they're telling us to graph h of x is equal to all of this times 5. Well, instead of going over 1, up 1, I'm going over 1, up 1 times 5 halves. Well, that's 2.5. And then instead of going over 1, up 3, I'm going 3 times 5 halves, which is, well, that's 15 over 2, which is 7.5. So this is going to look a lot different. So I'm going over 1, up 2.5. And then I'm going over 1, up 7.5. So there's a half. 2, 3, 4, 5, 6, 7. So notice we call this a stretch. A stretch is stretching to heaven. And a shrink is shrinking towards the x-axis. Like I've said on my YouTube channel, I can't cover every little example that we go through in this lesson, but I do want to make sure I get to the standard form. The standard form of a quadratic function is very important, and this is a new form for us. F of x is equal to a times x minus h, quantity squared, plus k, where a cannot be 0. If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. The axis is a vertical line where x is equal to h, and the vertex is the point at hk. So we are going to look at all of this together in example 2. The first thing that we're going to put to use is, well, remember we're going to go ahead and put it in this formula, x minus h quantity squared plus k. And we're going to have to remember how to use completing the square. So instead of writing f of x, I just write this as a y. And this constant right here, we are going to go ahead and bring it to the other side so we can complete the square on the one side. So if I bring that over, I have to subtract it. And from here, I have ax squared plus bx, and we are going to complete the square. Remember, what I add to one side, I do add to the other. What is half of 10? Half of 10 is 5. 5 squared is 25. So I'm going to fill that in a lighter purple. What I add to one side, I add to the other. So y, well, these would cancel out, is equal to the perfect square. And our goal is to get it in this form right here to make that perfect square of x minus 5. So in this case, my a is 1. And remember that if a is greater than 0, it's going to be a parabola that opens upward. They also tell us, notice I have nothing over here, that the hk is going to be our vertex. So I'm going to take the opposite of inside, it's a negative 5, so I know my vertex is going to be 5, and because there's nothing in the k position, it's going to be at 5, 0. Now this should make sense to us when we have to graph it, because remember our parent functions. You guys were super great with your parent functions. And this right here tells me to go left and right. Well, hey, look at that. This is going right, 5. So I'm going to graph this right, 5, 1, 2, 3, 4, 5, and put my dot. And then we're going to use that same pattern because my a is equal to 1. If a was equal to 2 or a half, then we would do the over 1 up something different. But in this case, I'm going to go from this point, I'm going to graph it in a light purple. I'm going to go over 1 up 1, over 1 up 3, over 1 up 1, over 1 up 3. And my graph is going to be a parabola. And let's name the things that they want us to name. The first thing they want us to identify is the vertex. I know my vertex is at hk, which we identified at 5, 0. We do know it has a minimum. The minimum is also at 5, 0, or the 0. So remember the minimum is just the vertex. Okay, and because this one's down, it would be a minimum. And the other thing that they didn't really ask us to do, but we're going to do, is notice this orange line is the axis of symmetry. And the axis of symmetry is a line. This line is x equals 5. Always write the axis of symmetry as a line. All right, so quickly, I'm going to try to do this next one just for this video. I'm going to continue this lesson. If I have y equals, remember I'm going to bring this to the other side. So I'm actually going to go ahead and erase that equals and just do y minus 7. Because this is going to help us complete the square. Before I do anything, I have to get rid of the 2 in front. So the 2 is going to be factored out. And then from there, I can complete the square. What I add to one side, I add to the other. So let's go ahead and see what happens here. Half of 4 is 2. 2 squared is 4. Did I really only add 4? No, because of the 2 on the outside, I really added 8. So this new equation is y plus 1 is equal to 2, and all of this is x plus 2 quantity squared. Now, I told my students they could leave it like this, because from here we could find the vertex. Some people like to show it with x plus 2 quantity squared minus 1. But I like it this way because we have to change both of the signs. In this case, you would just change the one side, and you'll see what I mean when I'm talking. So remember that this is h minus k inside, so this is going to be a negative 2. And then this -1 would be the rest of the vertex over here. I like to show my students, hey, let's just keep it, and we know this sign has to change, and so does the -1. So both sides have to change. Either way, you're smart kids. I know you guys can do this. All right, so that's the vertex. I know because it's a +2, we're going to go over 1 up 2, over 1 up 6, over 1 up. All right, so let's go ahead and do that. We're going to graph this one together. My vertex is at -2, -1. I'll go ahead and graph it in a different color. I'm going to go over 1 up 2, over 1 up 1, 2, 3, 4, 5, 6. So notice I'm just making that, and this is stretching big time to the heavens. And it might ask you the maximum or minimum. In this case, it is a minimum, and it is that same -2, -1. And the last thing we're going to talk about is that axis of symmetry. It's a symmetrical line that is an x equals line. And in this case, the axis of symmetry is x equals -2.